Alrighty, today we are going to be learning about adding integers. Let's go ahead and start by reviewing our integer poetry. You guys ready? Can we put them all in order, plot the points, and we just might? 'Cause the number that is greater is the number to the right. Opposites are easy, just switch the sign or go the same direction on the other side of Mr. Number line. An absolute value is happy, it feels like a hero.
'Cause it's the positive distance of the number from zero.
Very, very good. So we are going to talk about poetry for adding integers, okay? But for right now, we are going to go ahead and we are going to go through these steps, okay? So I want us to look at this first example for adding integers. It says 5 plus 3. You guys have seen math like that since kindergarten, right? But there is an invisible math symbol that's in front of every positive number that we don't write. So look at the 3. There's that little itty bitty plus sign, okay? So when you're adding two numbers on Mr. Number line, the first number is going to tell you where to start. We're going to plot that point. So this is us using Mr. Number line. So we are starting at 5. We're going to plot that point right there at 5. The sign of the second number tells us which direction to go. We go right for positive signs and left for negative signs. The second number tells us how far we are going to go. You can draw and label it. So I'm adding 3, and that 3 is positive. Therefore, I'm going to move 3 to the right. And where do I land? On 8. So what is 5 plus a positive 3? 8. Again, you've been doing problems like this since kindergarten, okay? We won't be doing subtraction until later. So right now, we're always going to see adding. But now let's look at example 2. Example 2, what's our starting point? 5, because it's our first number, so we're going to plot the point at 5. We're going to add, but we're adding a negative number. Well, which direction does it tell us to go if we have a negative sign? Left. Very good. So we will move 3 units in the direction to the left. 1, 2, 3. Where do we end up? 2. So 5 plus negative 3 equals 2. Can you think of another number sentence that would result in that same answer when you start with 5? James?
5 minus 2.
5 minus
3.
Very good. So 5 plus negative 3 is the same thing as saying 5 minus 3. You can almost replace that plus sign with a subtraction sign since you're adding a negative number. All right, go ahead and try examples 3 and 4 on your own. All right, what do you guys notice about example 3 that's different from the other ones? Chloe? It starts with a negative. Are my steps still going to be the same? Yes. I'm just going to be plotting at -5 first, and I'm adding 1, 2, 3. So what is my answer for -5 plus 3? -2. Very good. What about example 4? What was different about example 4? Finley?
It also started with a negative number, but the other number was also negative.
Very good. We started with a negative, and we added a negative. So I'm going to move 3 directions to the left, and my answer should be -8. 8. Very good. Go ahead and try examples 5 through 8 very quickly, and then we will come back together to talk about a rule so that you don't have to use Mr. Numberline if you don't want to. Alrighty, go ahead and check your work for examples 5 through 6. They should be 7, -5, 5, and -7. So now let's come up with a rule, and then we're going to come up with poetry. Okay, so let's examine our results from examples 1 through 8. When we simply added them together, we got 8. When we added a negative, we went backwards. When we started with a negative but added a positive, we went forwards on Mr. Numberline. When we added 2 negatives together, we went farther to the left. Again, just adding 2, moving to the right from where we started. Adding a negative, we're going to move over to the left. Moving to the right when we add a positive. And 2 negatives, we continue to move to the left. So let's answer some critical questions. For problems where the signs of the numbers were the same, so examples 1, 4, 5, and 8. The signs were the same. They were either both positive or both negative numbers. Did we add or subtract the absolute values of the numbers to get our answer? So let's take number 8 as an example. If I was to take the absolute value of -1, what would that be?
1.
And what's the absolute value of -6?
6.
What is 1 plus 6?
7.
So did we do that? Did we simply add the absolute values? Yes. So we added the absolute values. And then the sign stayed the same. If we started with 2 positives, we ended with a... When we started with 2 positives, when we added 2 positive numbers, we ended with a positive. When we started with 2 negative numbers, how did we end? Negative. We added the absolute values to get the number, the sum, but then the sign stayed the same. For problems where the signs of the numbers were different, like examples 2, 3, 6, and 7, did we add or subtract the absolute values of the numbers to get our answer? We subtracted. So now let's write some integer poetry. You guys ready? Let's do addition. It says, if the signs are the same, that's simply divine. Add the absolute values and keep the sign. If the signs are different, you need to take charge. Do big minus small and keep the sign of the large. So you're going to keep the sign of the larger number. So let's look at these examples. Over here, we have -5 minus -3. We're going to start by taking the absolute values. What's the absolute value of -5? 5. Absolute value of -3?
3.
3. So I get 8, right? But I need to keep the sign after I had added the absolute values. So my answer should be -8 because back where I started, they were both negative. Let's look at some examples where they were different. So -5 minus 3. What's the absolute value of -5? 5. What's the absolute value of 3? 3. Since they're opposite signs, we are going to subtract, right? 5 minus 3 equals 2. But we want to keep the sign of the larger number. So go back to where the problem started. Which one was bigger, the 5 or the 3? 5, right? So we were going to keep the sign of the 5, so my answer is going to be -2. Again, you do big minus small. So this is the only time where you are allowed to reorder a subtraction problem. Remember the commutative property, changing the order? What operations does the commutative property apply to? Addition and multiplication, not subtraction or division. This is the only circumstance where you can kind of cheat, okay? So, what is 7 plus 4?
11.
What is 7 plus -4?
3.
What is -7 plus -4?
-1.
What is -7 plus 4?
-3.
Very good. So when we're adding integers, we have the choice. We can either use our poetry to remember the rules of what to do, or when you get confused, you can try some examples on Mr. Numberline in order to figure out what to do.